your assignment sheet. So guys, if you would all take a look at your assignment sheet, and just a reminder, phones should be off and away, earbuds out. If you have to power those off.
What?
Is that possible?
Yeah.
Right? Fancy ones now, no wires. Okay. So taking a look at your assignment sheet, today we are doing proofs. Woohoo! Proofs. Do we have textbook homework tonight?
Question mark? No.
Don't. Just a worksheet, man. Now, when is the next time that I see you in class?
Next Friday.
Wednesday.
It's next Friday. Wednesday's PSAT day, which means it's not
Thursday night. We're gonna use these things about it.
Alright. So because this is a red day, I see you right now.
What's that study for? Oh, here it is. Okay. That only took 5 minutes. Monday, you don't have to come to school. Some of us do. You're more than welcome to bring us treats.
Wait, do we so we will, attendance won't matter for us that day?
Shut up.
So Monday, you don't have
Okay,
school.
not Monday, I'm thinking what's your voice? Okay, what's your voice? Not Monday, no, never mind, no.
Monday, you don't have school.
No, I know that.
Tuesday is a normal black day. Oh wait, I guess I do see your stinger
I'm
there.
thinking we can't.
That was close. I thought I was gonna have to go. No. Stingers never used for checking homework. So I don't know. Okay. Now the 16th is a red day, but it's PSAT day. Except the freshmen aren't in the PSAT. You're doing attendance is taken.
Why?
Because anytime there's a school day by law, we have to take attendance.
What purpose does this serve?
And then, but you don't go to your red day classes at all on the 16th. So I will not see you on the 16th. Do we understand?
What's 9th?
Someone hasn't been paying attention. Hold your questions, hold your thoughts. All right. Now, Thursday is again a black day. Stinger 7-8. And then the 18th is when we actually have class.
Yay.
So there is a week between now and our next official class, but thankfully I didn't see you for Stinger. But soak up today, since it's got to last you a week.
So I'm going to be like a sponge. I'm going to be a human sponge. Lay down in a puddle of information.
So Wednesday is across the entire nation when PSATs are administered. So sophomores and juniors have to do the PSAT. Freshmen don't do the PSAT, so they're having to do something else.
I'm going to be a sponge.
They're out. It's a school day, so you are required to attend.
What if I could be just like a puddle of information, like a sponge?
Marcus, not yours. Alright, quiet down, please. Attendance is taken on Wednesday, just like any other normal day. Alright, so keep in mind a week from today and next class. Now next class is just more practice, but we do have a quiz, so keep that in mind. There is a long time between now and next class, but it's just practice and quiz, right? I think that's it for that. And next class, you finally get some text.
Yay, I love
That's right now. Okay, so go ahead and get out your homework. I'm going to come check that while you're checking your answers.
Yeah, by the way.
But not the bottom part. So our theorems and postulates page, this first part that we filled in was from day 1, when we talked about our special angles and them being congruent supplementary. This is true only when the lines are parallel. Now, today we're learning, well, we're not necessarily learning anything new. Today we're doing proofs. I've oriented this about 5 times so far today.
When we started, class it was good.
That's what you think, right?
Okay. By now, though.
So today we are doing proofs, and there's no new way of how to do proofs, just new material on which we're doing proofs. So as we continue to do proofs throughout the year, whenever we do proofs, it's nothing new. We're just doing proofs with the material we've recently learned. So what we're doing today, again, there's no new way to do proofs, just now we're doing proofs with parallel and perpendicular lines. So just some reminders, when we do proofs, look at your given, see if you can translate that into anything more, see if you can say anything more about it. Look at your picture, see if you can say anything more from there, and then just try to draw your connections accordingly. Now, before we dive into our notes on proofs, let's go ahead and take all of our theorems and postulates we've learned so far and add it to our theorems and postulates page. So as we're doing our proofs, we have kind of a one-stop shop of where to look for them. So again, the top half already filled out. That's when we know our lines are parallel, then we can make our conclusions about supplementary and congruent. Then day 2, we looked at the converse of those postulates and theorems. And so when we're looking at the converse, so we start off with having the congruent or supplementary. And then our conclusion is parallel. So converse means our conclusion will be parallel. Okay, so we had corresponding angles postulate. Now we're doing the converse of it. If two lines in transversal form congruent corresponding angles, then the lines are parallel. Two lines in transversal form congruent alternate interior angles, then the lines are parallel. If two lines in transversal form supplementary, same side, interior angles, then the lines are parallel. And if two lines in a transversal form congruent alternate exterior angles, then the lines are parallel. Now we technically had one more because we're not going to neglect same side exterior. What was true about our same side exterior? So we also had, if we had supplementary same side exterior angles, then the lines are parallel. So this is just doing our converse of these. And then last class, I'm going to write converse just to re-emphasize. Okay. And so then last class, day 3, we reviewed our algebra ways to know if lines are parallel, perpendicular, or neither. But we added on 2 more geometry ways. They seem like common sense, but they're still important theorems. These theorems don't have titles, so we just have to write out the theorem. So 2 lines parallel, same line, then those 2 lines are parallel, then the 2 lines are parallel. And if 2 lines are perpendicular to the same line, then the 2 lines are parallel. Not terribly exciting, but crucial theorems. Okay, so this is what we've learned so far in this unit. Today we are going to add on one more theorem, and that's our perpendicular transversal theorem. And what I like about this is, one, it has a title, but also it tells us a key thing. Our transversal is perpendicular to something. All right. So our perpendicular transversal theorem says in a plane, if a transversal is perpendicular in a plane, if a transversal is perpendicular to one of 2 parallel lines, then, so in a plane, if a transversal is perpendicular to one of 2 parallel lines, then, let's see. Let's draw a picture of this. So it says we've got a set of parallel lines. and we've got a transversal, and they tell us, hey, it's perpendicular to one of them. Alright, so transversal is perpendicular to one of two parallel lines. What's our conclusion about the other parallel line? It's also perpendicular. Good. Then it is perpendicular to the other parallel line. Nothing really earth-shattering there. Pretty similar to what we talked about above, but it's actually quite helpful. So again, perpendicular transversal, we already have a set of parallel, and our transversal is perpendicular to one. It's got to be perpendicular to the other. Okay. Are there questions with that paper? So keep this paper out, so that as we go through our examples of proofs today, you can have your proofs do it. Sorry. Sure. Yes. Connell, come up this way, please. Did you get it figured out? Give me one more.
Oh, no.
Oh, we're good.
You get this one.
Oh, no, you're good.
You know, in the bakery section, next to the baked goods. Like the donuts.
All right, everyone should have in front of them the lesson 4 notes proofs. Is there anyone that did not get a copy? Okay, I want you guys to go ahead and try example 1 and 2. Try it individually first.
Already screwed up.
All right, let's go ahead and take a look at our example 1 and 2. All right, so we already established that step 3 was given. Just a heads up, it is because they split up our given. Nothing crazy happened there. And ideally, we all know step 1. Given. Okay. Now the pitfall you need to watch out for when you're doing proofs of parallel lines is make sure that if you are using your postulator theorem that says the angles are congruent or supplementary, that you actually have parallel lines. We can only say those when the lines are parallel. So I cannot say that 3 and 2 are congruent by alternate exterior angles theorem. Why?
Because we don't.
Yeah, we don't have A and B are parallel. I've got L and M are parallel, so I can go ahead and make all the connections I want. But 3 and 2 are on A and B, and those aren't parallel, so I can't use those postulates or theorems. So we want to somehow show 3 and 2 are congruent without using those, and once we've shown they're congruent, then we can use the converse. Alright, so for step 2, 1 and 3 are congruent. How do I know that's feature? Good, corresponding angles postulate. Make sure you have that postulate.
Oh, I said theorem.
Converse is incorrect because converse is when we're proving theorem.
No, I just smack everything except for the vertical spiral.
Alright, step 4. So if we can't say alternate exterior angles theorem, then how do I know that 2 and 3 are congruent? Beautiful, good. Transitive property. Substitution be fine. 2 is congruent to 1, which is congruent to 3, so 2 is congruent to 3. And now I have separately shown that 3 and 2 are congruent, and guess what? They're alternate exterior angles. So what is my reasoning for step 5?
The converse of alternate exterior angles.
Good. Converse of alternate exterior angles.
That's why.
So again, whenever we're proving that parallel using our special angles, we have to have comma squared.
Oh, okay.
See the difference there?
So we're trying to, when we're trying to, okay.
All right, questions with number 1? All right, so example 2, ideally it was pretty similar. Slightly different picture, pretty much the same thing. Our angles are in different locations and the lines were flipped around the other way, but similar idea. So we have L is parallel to N, and angle 1 is congruent to angle 2. 1 and 2 do not have a current relationship in terms of special angles. That's why they had to give us those for congruent. And again, notice L and N are my parallel lines. So I can only use theorems and postulates for angles sitting on those. Okay, so that was a given. I like to go and just write the given all together so I don't forget any pieces of it. Alright, what do you guys want to do next?
Three are congruent by corresponding angles possible.
Good. Angle 1, 3 are congruent. That is indeed by corresponding angles postulate.
We got the given.
I can say this because those lines are already parallel.
I got pretty.
I'm going to go and mark that on my diagram so I can see the connection that 3 and 2 are congruent. But how do I know that 3 and 2 are actually congruent?
Because the
They're transitive. I cannot use corresponding angles postulate. Why?
Because it didn't explicitly say that A and B are
Right. We don't have A and B are parallel, so I can't use those postulates and theorems until I have their parallel. Alright, so 3 and 2 by transitive. And then finally, now that I've shown my set of special angles are congruent, I can say the lines are parallel. What type of special angles are they? They're corresponding angles. So we're proving parallel. We want to say converse of corresponding angles. Converse of corresponding angles. Alright. Questions with example 2. Alright, so let's take a look at example 3. Now we are proving the theorem, thus we cannot use the theorem. What theorem am I proving here?
Perpendicular transversal theorem.
Not quite perpendicular transversal theorem. The conclusion for perpendicular transversals is that it's perpendicular.
2 lines are perpendicular to the same line, then 2 lines are perpendicular.
Very. Yes. So lines perpendicular to the same line, we see M and N are perpendicular to the same line, and those 2 lines are parallel. That's the theorem that we're proving. We cannot use it. If we were to use it, it'd be just a 2-step proof. Denzel, put it away. Alright, so just make yourself a note here. We are proving the theorem.
So you can't use a theorem.
Correct.
Precise.
Alright. So the first thing they tell us is M is perpendicular to L, and N is perpendicular to L. That is given. Alright. Now, as always, take a look at your given statement. Can I say anything else about that? Take a look at your picture. Can you say anything else about it? So take a look at my given statement. They told us they're perpendicular. What does that mean if they're perpendicular?
But they are
That they form to, or they meet to form right angles. Good. So I can go ahead and say then that angles 1 and 2 are right angles. I'm just going to use 1 and 2 because they labeled them. How nice. So angle 1 is a right angle. Angle 2 is a right angle. What's my reason?
definition of
They have the marking.
Definition of perpendicular lines. It says they're perpendicular. What does that mean to be perpendicular? To be at right angles. Definition of perpendicular lines.
Now, I will say, we use the same symbol for right angle as we do to indicate perpendicular. So if this were on a quiz or test and you said given because they had a picture, I would accept it. But because I'm specifically pulling it from my given, I say definition. Okay, now let's continue down the road of right angle. What is it? What do we know about right angles? They're 9 degrees. What else do we know?
They're all equal.
They're all congruent, right? So we've got two paths we can take. Either go down the path of saying their measures equal 90 degrees, or go down the path of saying that they're congruent. Well, you'd have to first state 90 degrees and then substitute. So to decide which way we're going, let's refresh our memories of what we're trying to prove here. We want to prove the lines are parallel. Now, what special angle relationship is there between 1 and 2? Corresponding. In order for our lines to be parallel, what do corresponding angles need to be? Congruent. Notice it wasn't measures equal, we want congruent. So it's probably going to be faster if we just go the route of congruent. If you go measures equal, that's fine. You just have to say measure of angle 1 equals 90, measure of angle 2 equals 90 by definition of right angles. Then set them equal by substitution or transitive. Then go ahead and switch it from measures to congruency. What allows me to switch from measures to congruency?
Congruent angles, theorem.
Close. Definition of congruent angles. And then you'd be right back on track. But since we have the right angle congruence theorem, let's use it. So we can say angle 1 is congruent to angle 2. And again, you can either use the title, right angle congruence theorem, or you can write out what it says. I'm going to do both for you. Right angle congruence theorem. And that just simply says all right angles are congruent. I don't care which one you write. Honestly, for this, they're about the same length. Okay. So now I've shown that, hey, a set of corresponding angles are congruent. So I can go ahead and say my lines are parallel. And what would be my reasoning there?
Converse of corresponding angles.
Postulate. Good. Converse of corresponding angles postulate. Converse for showing parallel. Corresponding angles is what we have. And it's postulate. Okay. Any questions with that? I feel like these proofs have been too easy. They're only 4 steps. Let's flip it over.
Yeah, can you get like a quick 10-stepper? 10
Say
steps.
what?
Like, the proofs are too easy. Can we get like a 10, maybe a 16 step?
No, yeah.
Is that your mind?
Alright, so on the back side, we have a shape. Awesome. Don't let the shape scare you. Focus on what are my parallel lines and what are my perpendicular lines. Very good. Okay. Alright. So they've given us that AU is perpendicular to QU. And then they've also told us that angles 1 and 2 are congruent. And we're trying to show that DQ is perpendicular to QU. This is what we want to show. What I would like for you to do is, you don't need to write anything down, but go ahead and discuss with your shoulder partner. Take about a minute or two. How would you go about this?
So what's the that segment AU? Angle 1. So what are we trying to do?
So we're trying to prove that DQ is, okay, and
All right, let's go ahead and take a look at this together.
No giving up.
You know what?
It's putting your left foot.
We're in class. All right, go ahead and write out your unit. Yeah.
That was a wonky cue.
And it's a smart word. There's a line that goes along.
Oh, you
That's the smart word.
Trying to draw a line on the board.
Oh,
The board said no.
You switched. I didn't say switch, just walk out.
Okay, so while Hannah's swipping things over there. So, one is our given. Go write that out. We've got given. Okay. So you were to talk with your short partner about thoughts of how we could go about this. There's a longer way, there's an easier way. What are your guys' thoughts?
We have
Let's
no
share
idea.
their thoughts. Lauren is talking, listen.
Converse of alternate interior.
Ooh, converse of alternate angles theorem, sweet. How convenient. If I look at my transversal here, angles 1 and 2 are indeed alternate interior, and they gave us their congruent. So Lauren, we're using the converse. What does that tell us?
That line QD and UA are parallel.
Good. Line QD and UA are parallel. Awesome. Very good. So line QD and UA are parallel, and that was by converse. And sorry, I think I cut you off before you actually said which converse it was.
Of alternate interior.
Good. Converse of alternate interior angles theorem. That was a biggie.
That was a big.
Give me a thumbs up right in front of you if you caught that. You
That
were
was
able
a
to do
big
that.
brain move.
Okay. So that was really important to being successful. So we've got now these two lines are parallel.
There's one. Unlike the rest of us. There's one like the rest of us.
Okay. Thoughts as to what we can do next?
No idea. No clue.
Substitute to the given. Ooh, I'm glad you said that. So when we get to lines, segments, lines, we can't substitute those in for perpendicular and parallel. We've got to focus on using our theorems. 2 lines parallel, same line are parallel, 2 lines perpendicular, same line are parallel, and our perpendicular transversal theorem. So I want everyone to take a look at those theorems on the bottom part of your theorems postures page. You can do substitution with lines and segments, but we can use those. Which of those can we use? It's the perpendicular transversal theorem? Is it a 6th one? Which one is it? Which of the perpendiculars is
I
it?
believe it's perpendicular transversal theorem.
Yeah, I believe it's a perpendicular transversal. Yes, it is perpendicular transversal.
Okay,
Yes.
So-
yes, it is.
if you think perpendicular transversal theorem, okay, one. So the one that's lines perpendicular same line are parallel, it's not called theorem 6, but hold up 6 for that. If you think it's that, hold up 6. If you think it's perpendicular transversal, hold up 10. I don't know. What do we think? Connell, you have to give me one of the two. Okay, I'm seeing most 10, so let's take a look at our perpendicular transversal theorem. Let's see if I agree with you. Our perpendicular transversal theorem says we have parallel lines, and we have our transversals perpendicular to one of them. What's our conclusion?
But the other one is.
It's perpendicular to the other one, right? So we need parallel, and it's perpendicular to one of them.
We do have
Do we have that?
We.
Hey, we've got parallel. Do we have it's perpendicular to one of them? Yeah, we've got our transversal here. It is perpendicular to one of my parallel lines, so what must my conclusion be?
The other is perpendicular.
Good, it's perpendicular to that other one. What lines are those? QU and QD? What? That's what we were trying to do in the first place.
Yo, get out.
QD, oh, I wrote it wrong. DQ. Make sure it matches your proof perfectly. DQ is perpendicular to QU. And what did we use again?
Perpendicular transversal theorem.
Perpendicular transversal theorem. Do write out the word transversal so you know it's transversal, not transitive.
Oh, smart.
Well, isn't it like
You'll get it.
No, I don't.
What was that?
when you saying angle or keep saying line?
This is segment, yeah. Segment's not in yet. There's
We did it.
Okay.
In threes.
So let's talk about the difference between these last two theorems on our theorems and postulates page. Perpendicular transversal theorem. We already have a set of parallel lines. Aiden, are you with us?
No.
We already have a set of parallel lines. Our transversal is perpendicular to one. Our conclusion is another perpendicular. The one above it says we don't have parallel lines. We have two perpendicular ones. The conclusion is the lines are parallel. Okay, so think of these together. Parallel, same line, are parallel. Perpendicular, same line, are parallel. The transversals where we kind of dissect that part. Okay, questions with our proof, for example. Right. If you forgot your perpendicular transversal theorem, you could go down the route of, okay, it's perpendicular, by definition, that's a right angle. Right angle has a measure of 90 degrees, by definition, right angle. Because these are parallel, we have same side interior angles, which means they must be supplementary. And then we can say this plus this equals 180, substitute 190, subtract away, show that that's 90, show that's a right angle, show that's perpendicular. It's going to be like an 8-step proof. So a lot faster if you have the perpendicular transversal. Okay? Alright, our next example, example 5. There are a few ways to do this, so I would like for you to first try this on your own. Now do keep in mind, our given says that the angles added to be 180 degrees. What does that mean? Supplementary. So if you want to use the fact that they're supplementary, you need to state that they're supplementary, and what would your reasoning be? Definition of supplementary. So again, there are multiple ways to do this. You may or may not need that step, but make sure you have that step should you need to use supplementary. So you're going to try this on your own first, and then we'll talk about it.
I already know what I need to do.
Carry on with your geometry. as always, once you finish, go and check with someone nearby. You have to keep in mind there are different ways to do this. We're going to compare, see how you guys did.
So you can see only four of them.
But what is the angle one is your son usually by the Prove exemplified in a different way. Oh Lord.
Yeah, 1 and 2 are Wait a second. Also, you said it's 4. Does it know that? Yes. We still want a big mistake. Oh, did you? I did, wait, one. Okay, so definition of something. Wait, no, yeah, so it's up to 4, and
What it is?
Yeah, you have to try that out.
Oh, okay. Oh, good for you.
And again, there are multiple ways to go about this. So, we said before lunch that we could go ahead and change this into saying that they're supplementary. You may or may not need that depending on which route you took. But who would like to go ahead and offer up the next step for us? We can do it.
Is it given to us that like 1 and 3 and 4 and 5 were vertical angles?
Yeah, so they are vertical angles. Now, no longer do I require you to define that in your proof. You can go ahead and just apply your vertical angles theorem. So we can go ahead and do vertical angles theorem. Okay. Do you want to do it with 1 and 3 and 4 and 5, or just 1 and 5?
Just 1 and 4.
Okay.
We did it with 1.
Okay. So we have angle 1 is congruent to angle 3. That is indeed my vertical angles theorem. So again, you no longer am I requiring you to define that they're vertical angles first. You're just going to apply your vertical angles theorem. All right. What would we like to do next? What's that?
You can say angle. Well, you're gonna have to say that they're supplementary to each other.
Go ahead and say so they're supplementary to each other. Okay. So, oops. Let's go ahead and take our step 1 and state that angle 1 and angle 2 are supplementary. What's my reasoning for this? Definition of what? Good, supplementary angles. Okay. And again, there are quite a few ways we can go about this. Probably most people would have had those 2 steps. Alright, what do you guys want to do next? Maybe let me ask this. For your final punchline, since we're proving lines are parallel, we had to do a converse or something. If you did converse of corresponding, raise your hand. Converse corresponding, okay. And back there. If you did converse of corresponding alternate X, did anyone do converse of alternate exterior? Converse of alternate interior? Converse of same side interior? We're going to have options here. Okay, it looks like most people did same side interior.
You're doing, 2 and 4.
Okay, so it looks like most people did converse of same side and tier, so we'll go that route and talk about another way to do it. So my same side and tier angles I do have are 3 and 2. Now, we need to get to the point where we show that those are supplementary. Conveniently, I have 1 and 2 are supplementary, and I have 1 and 3 are congruent. What do you think we can do? Substitute. So since 1 and 3 are congruent, and supplementary is talking about measures add up to something, we can replace that and say angle 3 and angle 2 are supplementary. And that is just substitution. And then now that I've shown that my same side and tier angles are supplementary, now I can go ahead and say, oh, same side and tier supplementary, and that means that my lines are parallel. So I can then say B is parallel to C, and that means by converse, of same side interior angles there. Now you might have done this similar approach, but gone about it a little differently. Here we went ahead and converted it to we kept it in the form of congruency. You could have done vertical angles theorem, then done the step, the measure of angle 1 equals the measure of angle 3. What would be my reasoning for that congruent step if we did it? Definition of congruent angles. And then you could replace measure of angle 1 with measure of angle 3. That would be your substitution. And then you would have the statement of angle 3 and 2 are supplementary by definition supplementary, and then that there. So you might have chosen to stick with your measures and shown it that way. We went ahead and converted it to supplementary and then did it that way. So if you stuck with your measures, you would have had 6 steps for that. So that's our same side to your angles way. I think, Denzel, can you share with us what you did? I like the other Good, good.
And then you make it angle 1 and 2 supplementary.
Good. So he went ahead and translated and said, all right, 1 and 2 are supplementary. Good.
And then you can see that angle 2 and 4 are form a linear pair.
Good. So he went ahead and said 2 and 4 were supplementary by linear pair postulate. Awesome.
So that, like, if you were to do given and then escape that 2 and 4?
Yeah, so you could have flip-flopped those steps. You could have said 2 and 4 are supplementary by linear pair postulate and then done that step. That would have been fine. And then what was your punchline after you said 2 and 4 were supplementary?
Well, then you can use a congruent supplements theorem to say that angle 1 is congruent to angle 4.
Very good. So after he has stated that 2 and 4 are supplementary, I'm going to write that over here. So he has this step, and he also had the step that angle 2 and angle 4 were supplementary. The congruent supplements theorem says 2 angles supplementary to the same angle allows us to say that those 2 angles are congruent. So that was your congruent supplements there. And then, Denzel, what was your final statement there when you said the lines are parallel?
The converse of corresponding.
Very good. Converse of corresponding. So that's another way to do it. I think it's a pretty clever way as well. So you don't use the vertical angles theorem, but taking the approach of we were given 1 and 2 are 180, say that they're supplementary, say that these are supplementary by linear pair postulate, and then use that congruent supplements theorem to show that the angles were congruent, converse of corresponding. Very good. All right, so again, multiple ways to do this. Those are just a couple of the different ways. Questions with that? Now, because I made you share with your shoulder partner, I'm not going to make you do example 6. We're doing a different way. We just talked about that. Instead, we're going to do some practice problems where I'm going to switch you guys up and pair you up with somebody randomly. You're going to get all your stuff together and move seats. So while I'm passing out the classwork, go ahead and gather your stuff all together. No. It's just moving for today. These are not like new permanent seats. Okay, good. I'm literally shuffling index cards. I like to be a little more purposeful when I choose your seats.
Last time I went to like made
Alright, so worksheet 6 is coming to you. Worksheet 6 is going to be due for extra practice. Alright, is there that did not get worksheet 6? Okay, so this is going to be for extra practice today and next class. So today we're just going to focus on doing the front side. So here in a moment I'm going to pair you up. You're going to actually get up and move to be sitting next to your partner. And you're just going to complete the front side. Okay, so wait until I say all of the pairs and then I'll have you guys do it. Front side is, yeah, with the, that one. That's it. Yeah, this can be, where it starts with number 1. Alright.
So then whenever you're equal, like then we can where I'm going. Not really, but I know where I'm.
Alright, keep working. I've gone ahead and thrown up the answers for those first 2 problems for you if you want to check those. But then again, keep working.
Okay. Angle 3 is
Yes.
5.
Oh,
Oh, definitely. Yes. Three. We have that one is a right angle. Oh, did you state that in there?
No, I got 2.
Okay. We could state that 1 and 3 are equal because of yeah.
Because like I know that that's and R are parallel.
R and S are parallel, so that means that S is Q.
Q and R.
So we go down.
So Q and R.
I'm saying
Yes. I feel special. Glad you guys didn't move seats as long as you guys. Alright, let's go ahead and find the crossing Alright guys, so let's take a look at 1 and 2. The air analysis for 2 was that the lines have to be on the same plane, co-planar, and they're not. But do we have questions on 1, A, B, or 2? Okay. Now 3, there were many different ways to do this. I'm going to show you the way that I did it this particular time. They gave us a lot of information about parallel lines and perpendicular lines. And we needed to show in the end that A and B were parallel. So essentially, we needed to show that A and B were perpendicular to the same line. So there are a variety of ways to do it. I really should have an additional step here that says Q is parallel to S. And that would be 2 lines parallel to the same line or parallel. And then because, so Q is parallel to S, so I have that drawn on there. And then since they told me that B was perpendicular to Q, it's going to be perpendicular to the other parallel line. So I went ahead and said it was perpendicular to the S as well. That's your perpendicular transversal here. And they already gave us A was perpendicular, so 2 lines perpendicular to the same line. These 2 lines are parallel. That was my last one. Again, there are multiple ways to go about this. That's probably the fastest way. So, if you happen to get past this, pretty much once you draw it, then it all comes together. You've got these 3 parallel lines, and we've got S and U. S is perpendicular to R, and U is perpendicular to T. And our answer for number 5 is no. They're not parallel, because if we were to put our corners together, that's 100 degrees and 100 degrees. Same side interior has to be supplementary. Those are not supplementary. Do we have general questions on this front side of our worksheet? So the back side we're just going to use for practice next class as well. If you want to see the answer to the key, is posted up on Blackboard if you didn't get a chance to look at it more in depth. But this is, again, that proof is basically a combination of lines parallel, same line or parallel, lines perpendicular, same line or parallel, and a perpendicular transversal here. Now, what is your homework?
Nothing. Enjoy.
Your homework will never be nothing. Worksheet 5, I'm going to pass it out to you. Worksheet 5.